Hello everyone. Guys, in this lecture we are going to discuss about energy balanced delay aware multipath routing using particle swarm optimization in wireless sensor network, and its short form is EBDA. Guys, in the previous lecture, last two lectures basically, we have focused on this particular objective, that is objective 1, that is how we have tried to limit the network lifetime by balancing the energy reduction in the non-clustered environment. And in this lecture, or we can say that in this proposal, we have tried to achieve two objectives. The first objective is by elongating the network lifetime by balancing the energy reduction, and the second objective that we have achieved in this particular proposal is here we have tried to minimize the energy consumption in the and the network nature is the non-clustered only. So let us move ahead. That is how we have achieved this particular thing, that that is elongating the network lifetime. So guys, in this video we are going to discuss about only the concept of multipath routing, and after that once we understand that how multipath routing works and what we need to determine basically in case of multipath routing, in this lecture we will learn only this, and after that in the second lecture we will discuss about the the formulation which basically ensures that the routing is energy balanced and the delay aware. And in the third lecture of this particular this series, that we will discuss about that how that particular mathematical formulation, which is mathematical formulation is in the form of kind of sequential quadratic programming that we have formulated here to achieve this particular purpose of energy balanced and delay aware routing. So in the third lecture of this particular this proposal, we will discuss about the particle swarm optimization, that is how we have achieved how we have tried to solve that particular mathematical formulation using particle swarm optimization as well. So for this proposal there are basically three there will be three videos corresponding to this only, and in the first video now we are starting the multipath routing. Here in case of this is the figure with respect to the sensor nodes are deployed in the random manner into the environment, and let us say consider the instance that how multipath routing works, that in case of single path routing, what we have seen in the last two lectures, that a particular node will send its whole of its data, incoming data, towards one of the parent node, and it will keep on transmitting its data towards its parent node till either parent node will be about to die, or some other kind of situation occurs due to which it will not be able to send its data. But in case of multipath routing, instead of sending the data only towards a single parent node, what happens is that here we can see that this a particular node, when it sends its data towards its parent node, it will not send the data only towards a single parent node, it will send the data all the possible parent node which lies in its parent set. So there can be here three paths are possible corresponding to this here we are showing the particular node, that and the possible paths are path 1, path 2, path 3. So the neighbor nodes are determined using corresponding to a particular ith node. The neighbor nodes are determined using this particular equation, and what this equation says that the neighbor list of ith node will contain the sj node, and where sj, the condition on sj should lie into the the set of sensor node, which is represented using s hat, and it can be the base station as well. And the second condition on this particular jth node will be the distance between ith and the jth node should be less than equals to the maximum distance between any two nodes in the network. Fine. So that's how this neighbor list is defined. And for example, here we can see that corresponding to the this particular ith node, here we can say that these are the 5 nodes will be there in its neighbor list. Okay, and these are the j, k, l, p, q, and corresponding to the mth node, its neighbor list will include the nth node and the base station. So base station can also be there in the neighbor list. Like here we can see that corresponding to the mth node it is present. And after that, once the neighbor nodes are determined, then the parent nodes corresponding to all the nodes are determined using this equation. And what this equation says that firstly the condition is that a particular corresponding to ith node, its parent set will include only those sensor node. Let sj is a sensor node, and the condition on sj is that firstly it should lie in the the neighbor list of ith node, and then the distance between the jth node and the base station should be less than equals to the the distance between ith node and the base station. So what this condition basically helps, how this equation will help us, that we will select the parent node only the nodes which lie towards the base station instead of away from the base station. Like here we can see that corresponding to ith node, its parent set will include only the j, k, and l node, and it will not include the p and q node, because the distance between the here if you consider the pth node sp, which is represented as sp, so the distance between I and p and the distance between p and base station, or we can say like the distance between I and the base station and the distance between P and the base station, which is more okay, we can say that the distance between P and the base station is more, so we cannot include this SP node into the parent set of I. So that's how this equation is working. And similarly the child node are defined corresponding to the ith node using this equation, and here all the things are same except the condition on this particular distance value. Here the distance between jth node and the base station should be greater than the distance between the ith node and the base station. So here these p and q will fall into the child set of this particular ith node. Now this here towards si to between we can see that as I have discussed earlier as well, that a node in case of multipath routing will send its data towards its all possible parent node. So how much fraction a node will how much fraction of the incoming data on a particular node it will send, how much fraction it will send towards a particular parent node. So this this is represented as this particular this fraction, or we can say that this fraction is represented here using lambda ij. And in the figure also we can see that lambda ij is okay, for example if the incoming data is 10 and the lambda ij value is for example 0.2, then the ith node will send the 2 out of 10 towards the jth node. So this is the concept of lambda ij. And the condition on lambda ij is that summation of lambda ij should be equals to 1, where j belongs to the parent of I. Also this lambda ij value should be lies between the 0 and 1, and also if the jth node does not belong to the parent of I, then in that case lambda ij will be 0. Okay, like here we can see that corresponding to the ith node, the SP and the Q node, SP and SQ node, they will have the lambda lambda IP and the lambda IQ that will be 0 as per this condition. Fine. fine. So and at the end, in case of multipath routing, what we have to determine is, we have to determine these the value of these lambda ij at the end, and that is how much fraction, because this decision basically helps us, that is how how we are balancing the load, how we are transmitting the load in a balanced manner towards the parent node. So that will be decided using this particular value of lambda ij. So the whole we at the end we have to determine this value of lambda ij, and in the next continuing lecture we will discuss that how we have we have formulated a mathematical formulation which basically helps in achieving this particular thing, that is energy balancing and delay aware routing. And also in that we will see that how we have determined this value of lambda ij, cause so that we can transmit the data towards the in the in the network in a balanced manner, and at the end we will achieve this particular thing, that is the objective of network lifetime elongation. So guys, I'm ending this this video here, and in the next lecture we will see how we have formulated the mathematical formulation. Thank you.